So this question, I'm going to end up using one of the identities, so you can pause and try it on your own. But whenever you see something cos and sine, and one of them is squared, then you immediately think of the Pythagorean identity, which is sine squared x plus cos squared x equals to 1. And basically, you'll always have to rearrange this. So I can't replace sine x, but I can replace cos squared x. And cos squared x is 1 minus sine squared x. So what I can do is just replace it here. So 1 minus sine squared x plus sine x equals to 1. I can expand this and simplify. So when I expand and simplify, I will get 2 minus 2 sine squared x. Plus sine x equals to 1. Rearrange it to, you can guess what's going to happen when you have something squared and then sine x, so we're back in the first situation. So ideally, what you want to do is move things around. I do want to make this positive, so actually I'm going to move everything to the left side. So I'm going to get, right side, so I'm going to get 2 sine squared x minus sine x minus 2 plus 1, simplify it. Okay. Oops. Okay. Num plus 1 minus 1. Okay. So again, I'm in this situation where I have a quadratic. I can rewrite this where u is sine x, and so I have 2u squared minus u minus 1 equals to 0. And again, you can solve this in any method. And again, I forgot to put the domain. This is 0 to 2 pi. So you can solve this again using any method, factorization. If it doesn't work, you can use the quadratic formula. Just directly putting in the values, you will get u equals to 1 and u equals to negative a half, which means sine x equals to 1, sine x equals to negative a half. And we're back to the situation in the first slide. We have one with a positive, one with a negative. So you should know how to deal with these. Okay. So I have sine inverse, and it's going to give me pi over 2. So I know that my answer here, my sign is positive, which means I need the first quadrant and the second quadrant, but actually pi over 2 lies precisely between the first and second quadrant, so this is the only solution. Then I could go to here and take, so this is negative, which means I'm looking at the third and the fourth quadrant. But I'm going to take the positive because it's easier to deal with. So I'm going to take sine inverse of 1 over 2. And if you know your table with all the exact values, this should be pi over 6. So the table with the exact values is this one. So you should know that that a sine of 1 over 2 is precisely pi over 6. So it's very useful to memorize this table. So now I have pi over 6, which is in the first quadrant. And this is my reference angle. This is my acute angle. So if I want it in the third quadrant, I'm going to take pi plus pi over 6. And if I want it in the fourth quadrant, I'm going to take 2 pi minus pi over 6. So in here, I'm going to get 7 pi over 6, yeah. And then in here, I'm going to get 11 pi over 6. So you can approximate these. We are within the 0 to 2 pi, and you can check your solutions to make sure that you got the right answers. But that's how you'd use the trigonometric identity within the function. And again, repeating what we did in the previous question, which is to use square, so you're ending up with a quadratic.